Here we are representing linear systems with a matrix. So a linear system, meaning our exponents on our variables are 1, and you can kind of see that here. And then we're converting basically the coefficients or the number in front of each of the variables with the matrix correspondence. So it's kind of important that everything links together. So however many variables we have, in this case we have x, y, z, and t, everything has to kind of link together with that. And then we can also kind of count the constant as another column of our matrix. So just to kind of get things with our coefficient, in front of x is a 1, a 4, a 3, in front of t is a 1, and then we have our equal sign, which is like a solid line, 0 on the top. So we have to make sure everything links together. And notice we're missing a variable down here. It looks like we're missing the y. So that's going to be a comparable or comparable linear system to the bottom one would be 7x comes first. So 7x on the bottom. We don't have a y here, so we have a placeholder. So that's going to be plus 0y as our placeholder. There's our coefficient, the 0. Then it's minus 5z, everything links together, minus 5z, and plus 7t. You have to order them. So make sure everything's in the same order. You can't have them jumbled up. Then we have our equal sign. That's kind of the divide right there, or not the operation divide, but the action of separation divide, and 4 as our constant. So this is kind of what they call a standard form, where the constant is by itself on the equal sign. And then notice that these are our variables. If it were me, I would have them in alphabetical order, but let's go ahead and just stick to the format that they have there. Okay, so I'll just go ahead and write it out on the top. 1x plus 4y plus 3z plus 1t equals 0. Now, if you are good enough at your math and you know what the coefficient is in front of these variables, it's a 1. You don't have to put it there, but I just like having it there as a placeholder, especially early on, so we can see how everything links together. Now, basically, all you're doing is a matrix has a bracket, and we use the coefficients of each one of these. We have a line as a separator, and then we have our constants by themselves on the other side. So on the top, it's a 1, 4, 3, 1, our separation line, and 0. On the bottom, can you see what it would be on the bottom? Don't forget any minus signs that are paired with any of your coefficients. So the first one is 7, 0, -5, 7, and our constant is 4. Okay, so then we're just looking for which one of these matches it exactly. And I don't think they're doing any operations on it, so we can flip things and have something that's equivalent, but they want something that's just the representation. So 1, 4, 3, 1, 0, 7, 0, -5, 7, and there we are right there. Okay, so the key here is make sure your variables are ordered in whatever ordering that you feel is appropriate, or kind of whatever ordering they give you initially. Just make sure all your systems are matching that same order. And then always we have kind of our constants separated at the end, and there's our representation there. See if we have anything different on the next one. And you're just filling it in. It's that same idea. So in this row 1, column 1, 8, row 1, column 2, -5, row 1, column 3, 19, row 2, column 1, 6, row 2, column 2, 11, row 2, column 3, 29. So just matching the numbers here and putting them in the same order. Notice the X's, the Y's, the equal signs, and the numbers are all lining up vertically.